Alrighty, going to be moving on to the last example for complex fractions. All right, so we're going to simplify each expression only using positive exponents in our answer. And so really we have to go back to what we learned in a previous lesson on how do we convert from negative exponents to positive exponents, and that's going to be very useful here. And so basically that rule is if I have x to the power of negative a, that is equivalent to the reciprocal of that, 1 over x to the a. Okay, so that's what we're going to be using right now to do this. And one other thing here, if I had a coefficient of a capital A, then that capital A would actually stay on top, because the only thing that is being raised to a negative exponent is the x. If it was in parentheses, then you would move this a to the bottom, because also the a is being raised to a negative exponent, but that's not the case here. The a would be left in the numerator, and in the denominator we would have x to the power of a. Okay, so just something to take note right there. All right, so let's go on right here. Then what I first want to do is rewrite everything so it's a positive exponent. Okay, so this right here would become 1 over r squared minus 1 over s. Okay, so I'm using my rule that I learned right here, and just so that we make sure that this is still accurate, we'll just get rid of this part. Okay, there you go. And so that's for that guy right there. And then here, now here's where this whole thing comes in, where only the r is being raised to the negative 1. So we leave the 4 in the numerator, and then it's r on the bottom, plus 1 over s squared. Okay, so what I've just done is I just applied this rule right here. Okay, I'm just going to use the second method that we've learned in this section, and that is I'm going to multiply everything by the common denominator. What is the common denominator between r squared, s, r, and s squared? Well, that's s squared, r squared. Okay, so I'm going to multiply it by r squared, s squared, r squared, s squared. Okay, so if I multiply this times 1 over r squared, and I'll just show that step there so we're not missing anything. So 1 times r squared s squared is just r squared s squared all over r squared. See that there? This times that gives us that, minus r squared times s squared times 1. That's r squared s squared all over s. Okay, and so I'm just dealing with the numerator right here. So if I simplify that now, those cancel out, and I get s squared minus this s will cancel out with one of those s's, leaving me with just r squared s. Okay, so this is the numerator we just simplified. But now let's simplify the denominator by multiplying this through now. Okay, so I'm going to multiply 4 times r squared s. That's all over r. Okay, so right now I'm multiplying this by my first term, which gives us this. Okay, so now r squared times s squared times 1 is r squared s squared all over s squared. So now if we simplify that now, what do we get right here? Well, that r will cancel out with that guy there, leaving us with just 4rs. S squares cancel, leaving us with just r squared. And that would be it. Great, so there's nothing, I mean, yeah, like you can factor out, let's see, an s, factor out an r, but nothing's going to cancel out, so we can leave it just like that. Okay. Same thing with this guy over here. We're going to go ahead and first convert it so that it's in positive exponents. So this right here becomes 2 over y. So the y gets moved to the numerator. Minus 3 over y squared. This right here becomes 1 over y squared. Plus 3 on top, and then over x. Great, so let's just multiply again. What is the common denominator between y, y squared, and x. Well, that's just going to, the common denominator is x squared, y squared. Okay. Oh, actually, no, not x squared. It would just be x, y squared. There we go. That makes sense. X, y squared. All right, so if we simplify the top here, so 2xy squared all over y, I'm just going to kind of do this now in one step right now. This y will cancel out with that 2 right there, so that means all we're left with is 2xy, okay? Because we did have a y on the bottom, but there's 2 on top and 1 on the bottom, so we only have 1 left on top. Minus, if I multiply this through, the y squares cancel, and all I have is negative 3x. All right, sweet. Here, 1 over y squared times xy squared, the y squares cancel, and all I have is 1 times x. So I have x. And then right here, I'll have 3. The x's cancel, so I'll have y squared. And there we go.